Andres Andreu from Bayshore Networks here. I'm going to show you some native Modbus over TCP security. I'll show you a small example using the Bayshore product and a Peloton policy. Now what you're going to see is important because during the recon phase of an attack chain, attacking entities can get very subjective data about the back end, and this allows them to craft specific and strategic attack vectors rather than blindly attacking a back end, not really knowing what's back there. So in the industrial sector, this is very important because when devices give out identification strings, it really is an information leakage issue. So let me get started here. So this 56.101 is going to be my Modbus slave, and so I'm going to start that guy up. And we're going to host on 56.101. And then here I'm going to run an actual client hitting the Modbus slave on 502. This is a simple fingerprint remote function call. And as you can see down here, the request went through and there's a response. And here on the client side, on the master side, we got a string. So this is our Modbus simulator right here. So now, if I route that same exact call through the Bayshore product with this Peloton policy here enforced, I'll show it to you in a second. It's the same backend, 56.101 on port 502. On the front side, it's going to be 56.125 on port 5555. The policy, and this is a simple one, just one rule, looks like this. So we'll copy this for syslog later, and we're going to deny that call natively at the Modbus level. So this time, we're going to make that same call, and as you can see down here, the request never made it to the back end, and on the master side, we got no values returned. So if we go to syslog and take a look here, you'll see that there's the one block and there's the call. Thank you for your time, and if you want to reach out for more information, reach us at info@bayshorenetworks.com.